Hello spider peeps. Okay, in this video we're going to do a what's inside of this spot welder, which you probably saw in a previous video. The reason I really want to take this apart is because my BFIRC, if that was what it was called, spot welder, had these really flat lipo cells in it. They failed, or something within that board failed. But what I wanted to see is what cells are inside this, because it might be more long-lived if I can replace them. I'm really hoping, because of this long case, that it's got 18650s in, because then it means that I can use things like laptop batteries to be able to give these a new lease of life if it ever goes kaput in the future. So let's see what's going on inside of this. It's a similar layout to the previous BFIRC one in that it's got these PCB panels on the end, and then it's aluminium extruding. Aluminium, very meltable. So let's try. I hope there's power in my wave stick. There is. Let's take these rather unexpectedly long screws out of this and see whether it will slide out. It's nice to see how well this has been made. I mean, there's no thread lock on that. It felt like there was, but there isn't. So if I pull that out, I've got a bad feeling about this. It's not 18650s, I can see already. Oh well, this is going to be a bit of a shame. But anyway, let's get the other side off and work out how it slides out. Okay, that's captive. How is that captive? It can't be. They must put these prongs on afterwards. So which way is it going to slide out then, spider peeps? Oh, it can only slide out this front way, can't it? Yeah, that's it. Oh. I mean, ironically, the problem with the other one was probably the fact that I took it apart. So just down there, look, see, it's got two flat lipo cells in. Well, I think there's two. It might be one that's folded, or it might just be one, which is a shame. I've seen these on Ali, the internal boards as well. So I suppose if it does go kaput, we can do something with the internal boards. That doesn't want to come out that way. Does that mean it's got to go out the other way? Or is it completely jammed now? Or maybe it's jammed on that bit. Jammed on something. Ah, look. It's jamming on that little window there. Let's try and push this out a little bit. I was worrying what this is going to short when you're doing this. Okay, so that's popped out. These switches are having trouble clearing the window. Look, yeah, those little switches are just jamming on it. So, jamming on it. There we go. I'll keep that way so I'll know which way it goes back in again. Some quite beefy looking thymistors probably there, transistors. Some nice hardware there that's, yeah, doing the battery terminals. Ah well, again, that's a pity. I was really hoping I was going to have 18650s in this, but at least we've got some record of what's on that, and I might be able to get that cell. Looks like they're soldered on. I thought if they came with tabs with holes on, that might be a nice way of being able to replace them. But yeah, so we've got a little OLED screen on that, some coils for the low voltage, little chip there, and one cell. JST 043125, and I suppose 2025, that's the serial number somehow. We'll see if we can find them on Ali, see how much we could get those for. But let's put this back together and try it, make sure it's still working. Hopefully it will be. Okay, so it came out that way. Make sure that I'm in the right channel inside. So there's only one channel inside it, just at the top above the fittings. So that can go in there. Make sure that that could have got exciting if I'd have pushed that in the wrong way. Some EVA foam there to keep the battery in place. Some more foam there. And at least we've got that, and that last bit isn't going in. So if I push them down a little bit there, then it'll go in. So just remember that if you're taking apart one of these. All right, pop that on there. Make it look nice and neat again. All right, so here's the big moment. Let's turn that on. All right, so that seems to be working. Now, when I used it in the other video, I charged it up to 4.2 volts. It's only 4 volts. I mean, I did probably about 10 welds. Yeah, so that's used 0.2 of a volt. Obviously, it's not a massively big battery in there. In fact, let's go and check the battery on Ali. 7043125. But none on there. Let's put JS in front of it. Well, either that wasn't the battery, that's not the model number. I bought this specifically off Amazon. This was a Hopbucan 80 gear OLED spot welder. I just can't be bothered to read the rest of it. Didn't have 18650s in it, but it'd been designed to weld 18650s, so that was alright. So this was £32. Thought it was a bit cheaper than that. Don't know whether it's gone up since I bought it. Let's just show you what else came with it. Some of the nickel for the battery welding, quite a fair bit of it. Oh, that nickel feels very thin. This is some of the nickel off the previous battery. That does feel thicker. Yeah, this is from the laptop battery that I took apart. Yeah, that's much thicker, so there's a lot of this, but it's quite thin, so maybe you'd need to double that up if you were using it for batteries. But I mean, I'd never trust the stuff you get with this anyway to make a battery out of. But I think I'm probably going to use these cells a different way anyway. Let's pop those away. And I also noticed that this comes with a little USB-C charger. Now, I mean, we all know what USB-C looks like, but the one thing that slightly annoyed me about this is that it didn't work with a PD charger. So mostly now all my chargers are PD. I had to use just a standard USB charger for this, even though it was USB-C. They're not all created equal, these leads, and this device just wouldn't take a charge. So you saw this working on my Wiener Welder video. Let's just try, and suppose I could just test this quickly by getting a bit of this and just try and welding it together. So let's see whether it welds this. Let's see whether it sets fire to the paper around it. I don't know, but let's zoom in and do it. And it does give a satisfying spark when it welds. Let's do this at the end so I can reuse some of this. There we go. So hopefully there's no electric shocks on this. And you don't have to push anything. All you have to do is push the prongs against the metal and it senses it and then fires. So, okay, a lot of smoke off that. God, it stinks as well. Oh no! That'll be where all the smoke comes from. Blow. My poor cutting mats. Okay, so don't do this on. I mean, that is... Yeah, I mean, it does pull off, but it always will. But yeah, it was quite a tough charge there. I wonder if what's the better way to do this. What else have I got? I'll tell you what I've got that's slightly safe. Here's just a bit of silicone off one of my moulds. Bit dusty, so let's try that again. Clear. Ooh, that shot a little bit of spark off. I do like the splat on the back. Oh yeah, it's the paper on it. I mean, it's not the best way to do this. In fact, I think that's blown a hole out of it. All right, so this isn't bad really. I mean, it's not going to last for too long, but I mean, I should have this turned off and not try it like that. But yeah, I mean, it works for what it is. You know, if you're making cells yourself, is it worth it? This is good for just playing about with. Is it worth it for actually trusting if you're making lithium battery banks? I'm not sure. Yeah, and I'm not sure how long lived it will be. All right, I hope you found that interesting, and see you in the next video. Bye. So just remember that if you're taking apart one of these. And my little window has completely stuck to my desk. Ah. Wow. Alright, pop that on there. It actually embedded a bit of the metal into the thing. Mental note, don't do this on a cutting mat.